Aaron Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey there, Meteorologist Aaron Tuttle with you. It is Lunchtime Live on a Thursday, about 10 minutes till noon. We're going to get you updated on what the weather's going to hold as we head past our weekend into that Monday. Take another look to see if that data has changed any. And of course, it's out there. It's windy already. Just be prepared. This is our windy time of the year. So there are many days we're going to get windy like this. I've had gusts at my anemometer, I think over 30 so far. So one of those deals. But it's actually kind of chilly. My temperature is at 60 degrees. So not exactly your normal afternoon temperature coming up. It'll be a little on the cooler side, but we're going to be warming things up pretty quickly as we head into the weekend, though. So we'll take a look at that also. But let's take a look outside right now. Currently, we do have those clear skies, and like I said, I'm at 60.8, I think it is. Winds will be gusting off and on throughout the day. Thanks again, you guys out there in YouTube world, joining in from Durant, Mustang, I see ya, and North Texas even. Mean Okies in the house. And on Rumble, good to see you. And also, of course, on Facebook. I'll put the link here if you want to join in. That way you get the notification when I go live. You can join the Facebook Weather Broadcast channel. That way you don't miss anything. So that'll be in your comments section. All right. So last night we talked about this. Gave you kind of an in-depth look at behind the scenes. I'll lift the curtain for you. I am the Wizard of Oz. I do lift the curtain and show you the machine and tell you what's happening behind the scenes. So out there currently for the forecast from the Storm Prediction Center, they are highlighting still that area for Oklahoma, and they've kind of expanded their little orange circle they had yesterday to a larger area. Now, what this means is just they do expect severe weather to occur across a larger region. In other words, probability is higher for that. It doesn't necessarily talk about the magnitude of severe weather. It just talks about the aerial coverage. That's really all that is. But if we do look at the algorithms, the language machine learning algorithms, they're right here. So they kind of favor the eastern half of Oklahoma for a higher probability of severe weather. And what this little shaded area you see right here, that's right about the Oklahoma City metro area, just on the east side between us and Tulsa. So kind of in that sweet spot. From basically bounding around I-40 and then north. So that's kind of like the magic spot in the machine learning. The Storm Prediction Center, as we said, has gone this big circle right here. So who's going to win? Man versus machine. If you look at the analogs going back in time for similar situations, again, it kind of favors the eastern panhandle and far western Oklahoma. And these things change every day as new data comes in. It tries to correlate and find some similar event from the past. There's a wind circle. Here is the hail probability circle, again higher across the western half of the state. And here's the tornado circle, which has a little minuscule 5% ring, again across the western parts of Oklahoma and toward the Panhandle region. And this is obviously even different from last night. It'll continue to be different as new data comes in. So here's a close-up view of that Monday severe risk. Weather Service is highlighting that all severe weather hazards are possible late afternoon and evening, and just to kind of check back off and on, put in the back of your mind that, yeah, at some point, you have to deal with a little bit of severe weather from Monday. Well, let's take a look, see what's happening in the upper levels of the atmosphere. So last night we looked, the American model, the GFS, was the lone outlier. It had its upper level low for this whole system way out here. Well, today it said, you know what, I'm going to join the party, albeit I'm a little late. So it's going to put its low right about here. Now the European, which is what we used last night for our discussion, is just at this basically the same spot. Now the icon model, which had been over here, has retrograded back to here. And the UK Met, which was also over here last night, has now retrograded back to here. So kind of half-stepped it. So obviously there's a lot more agreement now on the placement of where the upper level low is. And that's important because you have to have the storms form in relation to that low. And they all form east of the low track, and southeast, etc., northeast. So it's going to be west of Oklahoma, basically. Of course, how far west is important, and the timing is important, and the exact positions, all that stuff is important. But also what response that you get from how things evolve in the pattern. So let's just take a look again at the European. So last night, or yes, it's the last night's data. So in other words, this morning's data. Let me see if it's coming in yet. It is not yet. Usually it commences like 1 o'clock. But it kind of shifted the wind field back out to the west a little bit by 7 o'clock for the best dynamics aloft as far as shear. But it's, let's see, for the jet stream. But as we head into the 500 millibar pattern, you still have a nice little jet action here. And if we go into, let's see, let's go to 850. Also, still a good low-level jet in here, but everything's been kind of shifted west. So that was the big thing that the European did. Last night's data from where we talked about is actually shifted it west, just a hair. If we do look at the surface, where it's going to show you where the dry line is located. Again, the dry line separates the moist air from the dry air. This is the American model that I have on here right now. The Icon model is a little bit more to the west. UK Met, where are you at? Same with the Icon. Okay, let's go to the Canadian. Similar to the GFS, something like that. European, the most westward, just by a hair, something like that. And also the AI version of the European, same thing. So there you go. So now you're kind of getting a little bit more consolidation on the position of the dry line, which is going to be roughly here across the eastern Texas Panhandle as it looks right now, probably just east of Amarillo, which is standard. It typically happens when you have a system set up like so. Okay, and again, the dry line is where we get those storms to initially fire, and then they develop and move east from there. Let's take a look at the European. So at 4 or 5 o'clock in the afternoon, it does say, all right, we'll get some thunderstorms that will develop in this area along that dry line confluence and convergence. So there's a few things here. So at the initial point in time is a really nice photograph for the structure of the atmosphere. So in other words, the storm should turn quite well, and that's what's indicated here in these little wind fields. Possible hazard type of a tornado, a significant tornado as far as like an EF2, maybe even EF3, decent sized hail, 4 inches in diameter. So it's some decent shear. All right, so the thunderstorm or the model seems to indicate that the environment is favorable for some pretty nasty thunderstorms to develop with the potential of a tornado or two in that area. Now, if we go to the 0Z hour, which is 7 o'clock, those storms that were here fizzled. I'm like, well, where'd they go? I mean, here's some remnants of them, but I'm like, well, what happened here? So we have to kind of look at the model forecast of what it thinks that atmosphere is that the storm's running into. And what it's doing is it's stabilizing the atmosphere because it's producing a really strong cap. And the wind field is still becoming a little bit more linear. All right. So instead of turning with height, it's just more all from the south at various levels of the atmosphere in the lowest floor. And your cap strength pops up. So basically, in other words, it means, or this you have to look for signals what the model tells you versus just getting all excited and just painting, red all over the map and going nuts. So we look at devil in the details, what we do here. All right, so what it tells me is that these storms that do fire up out here in southwest Oklahoma at 4 and 5 o'clock, as they travel east, 5 to 6 to 7, they vaporize, they moose. They lose what the atmosphere was capable of producing. Up here in northwest Oklahoma, they hang on a little bit better because you have a little bit better situation. So again, a possible tornado type windshield looks a lot better. Still got some good turning. Takes a little while, but it does get there. And dew point temperature still look pretty good. Cap does start to build in though. There's a little nudge of it right here. This little red line that kinks out. So the atmosphere, in other words, up here is a little less cap. Therefore, these storms can still stay rooted, can still get moving. All right, so now let's take a look at the next 3-hour window because it goes in threes. So we'll go to 9 or 10 p.m. All right, so 10 p.m. all of a sudden we have storms bubble back up here in Oklahoma City and point south. We're like, well, where'd that come from, right? And you still have some more out here back on the dry line again. Okay, so let's take a look to see what the atmosphere looks like as they do that. Well, if we see, we have still some decent shear turning with height. However, we have a really significant cap right here, massive. So what that tells me that the model is trying to tell us is that we should be getting elevated thunderstorms that develop because of some elevated instability. Now, elevated thunderstorms typically do not produce tornadoes. They can produce some pretty decent hail, though. So that would be your main threat with these, should this thing evolve as it's projected. Let's go back out west to this initial cluster here, back closer to the dry line. Again, the shear looks pretty decent. The lifting condensation level is quite high, so cloud bases end up pretty high because you still have that cap that's built in here. So again, it's struggling, even though the model forecast says tornado potential hazard type. That's only if those storms can get really rooted in the boundary layer, and with the strong cap like that, they're probably going to be elevated. So what this model tells me is that it's got a lot of elevated looks to it. for storms into the evening hours. The best window for potential tornadoes up through about 6 o'clock, and that was it. So let's take a look here at midnight to 1 o'clock in the morning. Same idea. Let's see how this goes. Still this mixed elevated capping layer way up tall. So again, these are all elevated things. You can ignore tornado potential at that point in time because they can't produce in that environment. Let's go to Tulsa. Again, the cap should be pretty significant. There it is. Lid strength's well over 200 on the SIN. So that's just, they won't be surface-based storms. So there you go. All right, so if we take that, everything as it is, that's how the weather looks in Oklahoma. I'll take a zip down here to Dallas-Fort Worth just to show you their cap is even stronger. So a better indication of some elevated storm activity down there. So it can't really tap into any decent shear. So all these thunderstorms here are just garden variety storms with a little bit of mix of hail. Let's go up north toward the Kansas border. So head into there. Really decent speed shear, but obviously another cap building in. Last night the cap was a little weaker in the data. Today it's a little bit stronger. So again, that's a good sign. When I see this, and if this sort of play out as go, I'm like, all right, well, it won't be that bad. It won't be that big of a deal. If we do look at the tracks, though, these are what we call kind of like supercell type indications because you have these swaths of very heavy rainfall, which is about a 1/2 inch to 1 inch. In these little areas, that does indicate you will get some heavy downpours, some hail, and usually with supercells, you get a bit of a wind. And like we said, there may be potential there for tornadoes, especially maybe out here in southwest Oklahoma where things are a bit more favorable, and also up here in northwest Oklahoma. So looking at this model data, I would pick those two spots for the most likely area to see a tornado. All right. Now let's go to the American model. Again, remember, it just woke up today and says, oh, I think I'll join the party. So let's see what it does in the atmosphere to work with. All right. So it also has kind of a high cloud base out in southwest Oklahoma as those storms initiate by 5 o'clock. It has decent shear, though. So therefore, it does have a marginal tornado risk. If we look here across Oklahoma City, just to kind of see how our atmosphere looks, very linear. All right. So the shear in here does not turn with height. It is very stagnant from the south all the way up to several thousand feet. And we have a monster cap right here that, if we can get into the 80s, would or could get close to overcoming if we have a surface convergence enough to do so. But again, that surface convergence is out in the dry line, which is out west, so therefore we don't get anything here. All right, let's step forward in time. Let's see what happens. All of a sudden, boom, the whole thing just blows up. All right, so let's take a look, see what happens in the atmosphere at that point in time. So it still says marginal tornado, probably because it's going to be a QLCS type tornado event when that happens. That's what the atmosphere looks like when you look at the model output, because you still have a mostly southerly wind field all the way up for several thousand feet. It does not turn with height quick enough. You do have still a monster cap as well, and that's indicated here in the SIN, and Cape values are okay, they're 1,000. So in this particular case, because of the way it looks on this printout for the reflectivity or the precipitation look to it, the structure, this tells me that it would be a squall line, all right? And so that squall line, sometimes you can have those QLCS baby tornadoes that come out on the leading edge, that spin up. Those are very hard to predict and hard to track on radar because typically they're very small and they're very short-lived. We're talking sometimes the magnitude of seconds. Sometimes that can be that quick. But regardless, let's go to the next 3-hour window. It does show kind of a little bowing structure here, which usually indicates some damaging winds. Otherwise, there's that little squall line appendage all the way down the south, kind of weakens and breaks up down here in North Texas again. So, for example, if I look at Dallas in this model, huge cap, a lot of dry air spot here. So, yeah, it's the severity has kind of disappeared. Let's go up here to northeast Oklahoma, right on the border here of Arkansas. So, let's see here. Interesting enough, not much of a cap strength on this point in time, and only some minor turning with height. So, in other words, the line should continue. So it's nothing, atmosphere has changed. You'll probably still get maybe some QLCS type tornadoes within this, and you would get some damaging winds the way that looks. All right, let's go to the next 3 hours. And then it goes into the midnight hour to 1 o'clock, and it just fizzles fast. So it must have ran into something that atmosphere didn't like. Let's see, back east there, looks like that cap's built back in again in that little area. So it may just been a little bit of favorite area for a little window in time in the data, up here across northeast Oklahoma to keep it going for a little while longer, east of Tulsa, and then it hits a brick wall and it diminishes quite rapidly. And that means for Arkansas and you guys, Missouri, that everything just disappears overnight. And that's a lot of times is what happens in Arkansas. I mean, you guys watch. These things go all gangbusters, and they get to the border and they just poof, fall apart. It happens time and time again. Okay, so that's kind of how that whole situation looks. If we were to go with the QPF rainfall output, again, we're looking for supercell type indications in the data. You don't see that with the GFS. You see just one big complete blob of moisture of rainfall totals for the first 6-hour window as the storm starts and the next 6-hour window, because this goes by 6 hours at a time. You might have some hints at some tracks, maybe some supercells embedded within that if you're trying to interpret this data. Otherwise, it's one big cluster mess of just a big group, line of storms with some very heavy rainfall with it. So there you go. So the reason why I'm telling you that is because regardless and despite the forecast you're going to see for the next couple of days, I want to show you what actually is there in the data. That way you can take a lot of it with a grain of salt. Temperatures today, obviously we said like a little cool. We're talking about 60s, and tomorrow will be much better. 70s, Saturday, Sunday also, man, toasty, 88 degrees. That is warm. Even got some warm weather on Wednesday of next week, which reminds me, I did want to go and look at a map for all of that here for you, because I did want to kind of take a sneak peek in the weekend in case you guys be checking out and going, I'm out. I'm not going to be paying attention to the weather for the next couple of days. So just tell me now, what does it look like? All right, well, let's take a look. Okay, so for today, like I said, 60s mostly across the state. Let's go to Friday. Cool in the morning, 40s, 50s. Would you look at that? Hold on a second. You see these little blue areas up here in southeastern Kansas? Ooh, a little bit of a light freeze in this area, and also in southwest Missouri. Cold stuff in Bartlesville, about 35 degrees. Might get a little bit of frost up there, so guys, be careful, Bartlesville. Otherwise, we're going to warm things up pretty good, like we said, for Friday. So back into the 60s and 70s across the entire state. And then we're going to crank up the heat. So let's look at these 80s out here in the Panhandle, by the way. All right, let's go on into Saturday. So just zip on in. And there's Saturday afternoon. Yeah, let's see. Right there. So we've got the hot spot down here in southwest Oklahoma in the mid-80s, upper 80s out here in the Panhandle. And then that'll lead us into Sunday. I'll change models and we'll figure that out. And that's where I think the temperatures really soar. All right, so Sunday, there's mid-80s here at lunchtime. Let's go late afternoon. 88 degrees, Oklahoma City. 90 out here in Elk City. Pretty much 90s right here in this little sweet spot, southwest Oklahoma. And 90s up here across from Enid, Ponca City, out toward Woodward. There's your hot spot of the state on Sunday. Woo, scorcher. And like I said, it's going to be breezy, so we'll take a look here. So let's go breezy today. Gusts up to around 30. Then it calms down a little bit for Friday morning, hence the frost up in far northern Oklahoma, northeast Oklahoma and Kansas, freeze. All right, let's go to Friday afternoon. Not so bad. Still wind gusts up to close to 30. And then Friday night and Saturday, they get really windy there for a while. Saturday, winds gusting up around 40 miles per hour. So obviously remember, this time of the year, you still have to deal with fire dangers just anytime you have the strong winds until we get all that vegetation to turn green for us. And then over on Saturday onto Sunday, wind speeds are still up on the gusty side. Looks like about late afternoon, they calm down just a bit after a breezy morning. So there you go. So bouty bout. That's an old throwback. Bouty and rowdy of some wind across the state over the weekend, all from the south and southwest. Okay, and otherwise no rain, so things are looking good there. Okay, so that was pretty much the whole thing I want to give you. So if you're late, you missed last night, like, I don't know what's going on, what's happening. No storms until Monday, just windy until then, and getting warmer. And then we'll look for a storm system coming here for Monday afternoon and Monday night. Right now, the models are kind of doing this as far as where the best shear is, where the cap will build in, where the dry line sets up. All we know is that there will be some storms. All we know it's a good storm system. It's the track is close enough to be concerning as far as severe weather is concerned. And then you will deal with the typical stuff, brief flooding rains, lightning, hail, wind, and hail can be quite large. You might have some, one of those deals, you get a few storms, and there could get to the grapefruit size or something if the stars align just right. And then, yeah, I'll probably end up with a couple of tornadoes. Either maybe a kind of a hybrid situation. You get a couple of tornadoes, maybe southwest and northwest Oklahoma at the beginning of the event, and then maybe it'll transition more to a squall line. Depends on which model data you go for. If you go for the American GFS model, it's more of a squall line with some QLCS tornadoes along the leading edge of it. And then if it is a supercell type stuff, well, obviously you have less tornadoes in that case, but that one particular storm can produce multiple as it continues to move along. And so we'll see which one of those pan out. And maybe neither one will pan out. Maybe something else that won't show up in the data until we hit Saturday and Sunday. So that's why I like to talk about the tornado risk, about 48 hours, the window. That's when I like to start talking about it with certainty, right? Because beyond that, there's way too many things that can go wrong. And let me tell you, it is very difficult to get a tornado. It is not easy. It is so not easy. You can have all these ingredients, and if they're off just by a hair, you don't get one. So that's you need to know that first and foremost. And then secondly, when it does come to the QLCS ones, if you're new here, like I don't even know what the heck you're even talking about. What is that? Supercell, what is that? Okay, supercell is one big thunderstorm all by itself. It has a mesocyclone that rotates, and it's what produces the tornadoes. And sometimes those can produce the larger ones. All right, mostly they're still the smaller ones. QLCS is just a long and leaning on of storms. Think of a glorified dust devil. You ever see a dust devil just kind of go out in the middle of clear air, right? Called clear air vortex. Well, that's all you need. Sometimes we have those in the atmosphere. You don't see them because they're invisible, right? But they're there. Well, if you have an updraft and like a squall line, just a line of storms come in, and a little updraft takes that along the leading edge and tilts it up, this little what we call vorticity, tilts it into that and spins it because it's already spinning, right? And then now it's like adding gasoline to a fire. All of a sudden, like, whoa, well, let me just magnify this. Woof, there you go. You got a quick little QLCS, what I like to call baby tornadoes. Typically because they're EF0s or EF1s, usually the very small ones. It is very rare that I've seen to get a QLCS that's a 2 or a 3. I have seen it, but it didn't last long, and it was so few and far between. It's on the statistical side, it's on the bottom end. So that's usually what we have to deal with. So those two. And then you know what? In the past, we didn't even count QLCS tornadoes. First off, we didn't know they were there. But radars have gotten much better on the sensitivity side and the resolution side, and now we're able to pick them out as long as they're close enough. So again, back in the day, we didn't even count those things. We didn't even know they were happening. Nowadays, we do, and so now we count them. So that inflates the low numbers of tornadoes across the country. As a result, over the last few years, probably 10 years, there's a lot more EF0s, EF1s that show up. But overall, the trend of tornadoes has not increased, especially violent ones. It's actually gone down. So that's always good. But anyway, that's it for me. I'm going to get back to lunch. I hope you guys also get back to your lunch and have a great rest of your Thursday. I'll still do a couple lives here off and on between now, obviously, and Monday. That way you have all the information you need to prepare and plan. And we'll see you and hope you have a great rest of your day. Take care. Bye-bye.